morning, students. In this class, we will learn geomagnetism, causes of earth magnetism, and to study the magnetic field and properties of earth magnetism by using three elements, namely magnetic declination, magnetic inclination, and horizontal component of earth magnetic field. Now, that concepts we will learn today's class. Geomagnetism. The study of Earth's magnetism is called geomagnetism. How Earth behaves like a magnet. In earlier 1600, one scientist named William Gilbert, he thought that under the Earth a big, huge bar magnet is buried. Because of that magnet, the Earth got the properties of magnet. Now, and also thought that because of the huge magnet only, it acquires the properties of magnet. And one more thing, see, what are the theories which is saying Earth is behaves like a magnet? Few theories. What are the theories? We will see one by one. See, already you know, in atmosphere contains electrons and ions. These electrons and ions are continuously moving, continuously drifting from one point to another point. That is causing electric currents. Because of this electric current, Earth acquires magnetism. That is the one theory. And in another theory, the Earth is somewhat, some 1,000 years ago, few million years ago, it is separated from the sun, and it acquires the property of magnetism. It takes from the property of magnetism from the sun. This is another theory. And one more theory came. What is the theory? Inside the Earth, the molten fluids which are continuously flowing from one point to another point. Because of these molten fluids, it creating electric currents. That electric currents are causing the magnetism. So this effect we call it as a dynamo effect. Once again, the molten fluids inside the Earth, they are flowing from one point to another point, continuously rotating. Because of that one, they set up electric currents. Because of this electric currents, magnetism is formed, and this effect we call it as a dynamo effect. And most probably, maximum 90% of the scientists believe that the Earth magnetism is caused because of this reason. Now, before going to the study of magnetic field and of Earth, we need three important elements. What are the important elements? The first one is magnetic declination, and second one is magnetic inclination, or it is also called as dip. And the third one is horizontal component of Earth's magnetic field. This is also called as BH. By using these three elements, we can know the study of Earth's magnetic field. Now, here I am drawing the diagram. See, this is our Earth. This is the axis. This we call it as a geographic axis. This is geographic north. This is geographic south. Now here one huge magnet is buried. Because of this huge magnet, this end becomes magnetic north and this end becomes magnetic south. This is the original axis of the earth, and this is the true geometric north and this is the true geometric south. And here earth magnet is there, and the line which is passing through this magnet, we call it as a magnetic meridian. The line which is passing through geographic north and geographic south, we call it as a geographic meridian. This is geographic meridian and this is magnetic meridian. This is geographic meridian, magnetic meridian and its axis. Now these two are at angle of 11.3 degrees. The angle between geographic meridian and magnetic meridian is 11.3 degrees. Now this is the geographic equator and this is the magnetic equator. That is the geographic equator and this is the magnetic equator. And the earth magnetic lines are passing like this. Now, before entering to learn the elements, everybody must know few basic terminologies. What are they? What is the meaning of geographic meridian? What is the meaning of magnetic meridian? See, the line which is passing through the geographic north and geographic south, that line we call it as a geographic meridian. The line which is passing through magnetic north and magnetic south, it is called magnetic meridian. Now there is an angle between 1.3 degrees is there between geographic meridian and magnetic meridian, and this line is geographic equator and this line is magnetic equator. Now from this one we know all these three elements one by one. Now say first one, magnetic declination. Suppose if you are observing the earth like this, I already told you this is the geographic meridian and this is the magnetic meridian. Geographic meridian and this is the magnetic meridian. Then what is the meaning of magnetic declination? The angle between geographic meridian and magnetic meridian, this angle we call it as a declination. The angle between geographic meridian and magnetic meridian, that angle we call it as a magnetic declination. It is represented by symbol D, but its value varies from point to point. Now one more quantity, namely magnetic inclination, or dip. Now I am observing all these quantities horizontally. Suppose if I am taking one vertical circle, this is the vertical circle, In this vertical circle, this is the one compass needle. This is the one compass needle. One compass needle. Now, if you are observing the meter like this vertical axis, the point where the total intensity of the magnetic field is acting, it is called as B. This is the direction where the total intensity of magnetic field is acting. If you resolve this one into two components, this value will be, this is B, this value will be BH cos theta, and this value, vertical value will be B sin theta. Vertical component BB sin theta. Now, the total intensity of the electromagnetic field is acting in this direction. Now, the total intensity of the electromagnetic field I am resolving into two components, one horizontal component and one vertical component. The horizontal component BH cos theta and vertical component BB sin theta. But the angle between the total intensity of the electromagnetic field and horizontal direction of electromagnetic field, this angle we can call it as a dip or inclination. The angle between the total intensity of the electromagnetic field and its horizontal component of electromagnetic field in magnetic meridian, that angle we call it as a magnetic inclination or dip. Its value is 0 at the equator, its value is 90 at the poles. So that value is also varying from point to point. And the third quantity, horizontal component of Earth's magnetic field, that is BH. Horizontal component of Earth's magnetic field, and it is defined as the total intensity of electromagnetic field in horizontal direction in magnetic meridian, that we call it as a horizontal component of Earth's magnetic field. It is represented by the symbol BH. It is represented by symbol BH. So once again, all of you see, try to understand the three definitions: inclination, declination, and horizontal component of Earth's magnetic field. Declination is nothing but the angle between geographic meridian and magnetic meridian. This angle we call it as a declination, symbol D. And here, inclination is nothing but the angle between total intensity of electromagnetic field and horizontal component of electromagnetic field. That angle we call it as a inclination. And what is the meaning of horizontal component of electromagnetic field? The total magnetic field in horizontal direction in the magnetic meridian, that is called horizontal component of Earth's magnetic field. Now, from this one, we can see few important relations also. See, now, horizontal component of magnetic field, I can write as BH is equal to BE cos theta, and vertical component of magnetic field, I can write BE sin theta. Now I can write BE by BH is equal to BE sin theta by BE cos theta. BE cancel, that is tan theta is equal to BE by BH, or theta is equal to tan inverse BB by BH. This is the one way. And one more thing we can write, squaring and adding equations 1 and 2, that is BE square cos square theta plus BE square sin square theta is equal to BE square plus BH square, that is BE square is equal to BB square plus BH square, and finally the BE is equal to square root of BB square plus BH square. So by using this relation, the total magnetic field we can find by using magnetometer. So once again, I'm recollecting all those things. You see, the study of earth magnetic field is called geomagnetism. That geomagnetism is caused due to the molten fluids which are flowing inside there, that creating electric currents. That electric currents are causing magnetism. Now afterwards, I draw the earth magnetism diagram. This is geographic north, geographic south, magnetic north, magnetic south. This is geographic meridian and this is magnetic meridian. The angle between these two, we call it as a magnetic declination. And magnetic inclination is nothing but it is a vertical plane. In the vertical plane, the total intensity of magnetic field is acting in this direction. It's horizontal, it's vertical. The angle between total intensity of magnetic field and horizontal component of magnetic field, that angle we call it as a magnetic inclination or dip. And lastly, the horizontal component of earth magnetic field, the total intensity of magnetic field in horizontal direction, that is called as horizontal component of magnetic field, that is represented by symbol BH.